everyone for joining us today, especially for the last session at SUSECon. I appreciate your time. Today we're talking about building resilience for modern applications, architecting disaster recovery for Rancher. Next slide. And what we're going to talk about today. So I'm going to kick things off. I'm going to talk a little bit about why data resilience even matters, especially for bigger enterprise-grade workloads. I will have Chris talk to you a little bit more about how to architect disaster recovery, specifically in a containerized environment. And then I will kick back in, talk about how Rancher and Portworx can help solve for data resilience. And then Chris will wrap things up with an async DR demo on Portworx and the Rancher UI. So quick intro, my name is Janet. I am a senior product marketing manager at Portworx. And Chris, do you want to give a quick intro?
Yeah, Chris Crow. I am a technical marketing manager. I have to actually look at the slide. It changes a bit. And generally play with technology for a living, which is a fun gig, I won't lie.
So let's kick things off. Why data resilience actually matters. Next slide. Next slide. So a couple years ago, I'm sure many of you here in the room know this, but a lot of the conversations around Kubernetes were based around Kubernetes adoption, whether or not you're adopting Kubernetes at all in your environments. Now we see that Kubernetes has hit more of an inflection point. So we're moving past kind of the early adopter phase of the bell curve, if you will. And as it moves more towards a majority, what we're actually seeing is that there is a maturation of Kubernetes applications. So it's not just about are you adopting, but what kinds of workloads are you building in Kubernetes? And we at Portworx ran a data survey last year called the Voice of Kubernetes Experts. We surveyed over 500 folks in the Kubernetes space running data on Kubernetes in their enterprises. And of that cohort, a large majority, and this is, you can see up here, 97% are using Kubernetes environments for data-intensive workloads like AI/ML, like databases. So again, that conversation is more turning into what kinds of applications are you running in Kubernetes. And spoiler alert, it is mission-critical applications. And we see this a lot in big enterprises as well, kind of across the gamut. But here you'll see a couple photo representations of how Portworx customers are actually using mission-critical applications in their cloud-native environments. I can't name all of them, but we have credit card companies that are driving faster credit card transactions. We have telecommunications companies, so anytime you're texting, using 5G, looking up where the nearest Chipotle is, that's all being run by Kubernetes. And then, of course, I'm sure you've heard from Rivian, both on the keynote stage, and I think they also ran their own session here at KubeCon, or not KubeCon, SUSECon, if you saw it. But they are also running mission-critical applications on their showroom, on their show floors to help drive, or factory floors, I should say, to help drive their manufacturing processes and make sure that's all running smoothly. And I'm going to talk more about them later, actually. So when we think about those types of applications that are being built in these cloud-native environments, you really don't want that to have any type of outage, right? If you can't make a text or make a phone call, or if the factory floor shuts down. These are all highly critical applications. The outages, if there are extended outages, the consequences are fairly severe, especially if you're thinking about certain industries that have regulatory compliance requirements, like telecommunications, like healthcare, like financial services. So these stats are all from the Uptime Institute. 54% of orgs say that their most recent significant outage cost over $100,000. 16% said it costs over $1 million. I know that sounds like a lot. That has a lot of different costs that are factored into it, like losing revenue, or some more hidden costs like your IT teams dropping everything and trying to get your applications back up. And then, of course, 80% said that their most recent outage could have been prevented with better management processes or configuration. So there's a lot of room for improvement here. And the next slide, we'll get into what some of those improvements could look like. So some of the characteristics that you may want to consider for a performant business continuity and disaster recovery solution. For these highly mission-critical applications, there's really no tolerance for data loss. So that's where we see zero RPO, low RTO. This is going to be that synchronous disaster recovery. Modern applications do come with their own capabilities like self-healing and all of that good stuff. but that's really not going to cut it for these highly critical applications. So that's when you need synchronous recovery. Anytime you're making a change to your primary production copy, you're going to see that in your DR copy. So if all you need to do is hit a button, failover, and you're back online. And no data loss either. Another key thing is software integration. So I'm sure everyone also knows, but in the cloud native space, things are constantly changing. You're adopting new tools, new technologies, you're improving your workflows constantly, and when you make those changes, you don't want your disaster recovery to be compromised. You want that to be tightly integrated so any changes don't affect your protection. And flexible DR policies, I'm sure everyone in this room also knows, but not all applications are made equal. If you're doing synchronous replication for every single one of your applications, that gets very complex, very expensive, very fast. Can't really do that in this economy, right? Or really any economy. So you want to be able to have flexible policies that meet the needs of each application so that you're able to tailor it to those precise needs. Finally, we have automation. In the event of an outage, you really don't want developers digging through documentation. You don't want them trying to write complex manual scripts in the moment. You want them to be able to quickly bring your applications back online. So that's the big consideration for this final pillar. And now I will pass things off to Chris, who will talk about
That's right. We did rearrange this a little bit because I do love kind of a consultative approach to disaster recovery. So my background was in data center consulting, of course, the VMware networking and storage background, and have recently moved, I guess recently is a relative term, but into modern applications. So I'm going to spend a moment, though, putting on kind of my traditional infrastructure hat when we're talking to companies about how to architect disaster recovery. Because a lot of these principles still translate, and I think are especially important when we're talking about modern applications. Because after all, it's always tempting to think about a Kubernetes infrastructure as an API endpoint that will always be available, that we can always push stuff to, but especially when we're dealing with data. It's important that we have a plan for how we're going to recover that data in the event of disasters, which can, of course, be anywhere from an actual natural disaster all the way down to a ransomware attack or a fumbling bearded graybeard that pushes the wrong button and accidentally deletes an application. Not that that has ever happened to me, of course. Of course, we're always going to start with the business requirements. Those initial thoughts about that Janet brought up about how much is this costing you for an application outage is an important place to start. Because, of course, we can architect disaster recovery in a myriad of ways. From, hey, we have a full day to get up. It really doesn't matter. My business is selling barbecue, and my web presence isn't the thing that sells me barbecue. All the way to I know how many thousands of dollars a minute my infrastructure is down is costing me. So make sure you have those conversations, and especially with business owners and application owners. If this was a larger workshop, we could really get into some of these sorts of concepts, but of course we only have 30 minutes. Of course, the basics of make sure you understand your recovery point objective. How much data can you afford to lose in the event of a disaster? And again, that disaster being defined, it could be an AWS regional outage, it could be a building fire, it could be an internet outage, or data simply being unavailable, or I should say your application simply being unavailable. Understand your recovery time objectives. How long do you have to bring that back up in order to fulfill whatever obligations you have to the business? This directly deals with that equation, of course, of how much money this is costing us. And then one thing I love to talk about is consistency points. Make sure you understand consistency points of applications, especially as we're splitting things out into multiple data services. We can start getting into some weird things. If I snap my Microsoft SQL database and it's different, that's handling authentication, that's different than my Mongo document database that's handling all of my barbecue orders, then I'm going to have a consistency problem. So make sure for DR events that we have a way of dealing with that, especially because oftentimes DR plans are not just we activate on another site, but we activate and then realize something isn't going to work and need to roll back. Say in the case of like a ransomware attack. When was that detection point and did your replication happen? This is especially important with synchronous replication because after all, in that scenario, what happens when somebody encrypts an application? Well, it's immediately jumped over to your other side. So making sure you have those consistency points. But in Kubernetes, it's also important because your data may differ from your manifests. I'll get into that a little more. But I do want to mention as well, because many disaster recovery plans are also going to include application level recovery. We can, of course, when we're trying to make an application available, my Mongo database could have, shards across multiple regions with multiple resiliency things. Okay. So when you're designing a disaster recovery scenario, keeping in mind that we have a lot of tools within the application to be able to do that, but it's always going to be, by definition, a boutique solution. How I protect Mongo is an application that is a Mongo backend, very different from how I'm going to be doing it with Postgres. This is where I become a fan of having an infrastructure level recovery option. Because if I am handling this inside of just Kubernetes, then it's manifests and it's data. And whether that data is a Mongo database or a Postgres database or Kafka or anything else that's in my system, I protect it the same way. I simply take manifests and along with the data and replay them somewhere else, which means maybe not for every application, but for a lot of applications to kind of have this universal way of recovering them. And that's not to say that you have to choose one or the other. Oftentimes it's, I'm protecting everything with infrastructure, and then my most important applications are being protected with something that's application level as well. Okay. I kind of touched on this a little bit, but making sure that, of course, when we were all in VMs, that virtual machine had all of the configuration data, and it had all of the data as part of it. So I could take that as a nice, neat package and move it to another site. But with Kubernetes, I do need to account for these manifests, because my manifest on a well-designed Kubernetes application is going to have configuration data. It's going to have port numbers. It's going to have the version of Mongo or Postgres or the application that I'm running. That needs to be accounted for, and we need to be thinking about that when it comes to those consistency points. Because if I don't, I can run into a scenario where I'm using an old manifest because, oh, maybe I didn't back it up. Maybe I don't have a GitOps pipeline, and I lost that definition. So I'm trying to bring up an application, or a Mongo database we'll use as my usual example, where I'm trying to bring up this data with an image that's out of date. This can lead to problems. Of course, and we're not going to talk as much about it today, but just as important as getting the data in the Kubernetes application over, ensuring that you have access to that application, whether that's global load balancers or, in my case, often just swinging over DNS with automating Route 53, but some way of doing that. And I get this question a lot because what I'm going to show you today is we're actually going to be protecting both manifests and data, but as we're moving more and more to GitOps pipelines and that single source of truth is sitting inside of a Git repository, having a disaster recovery product solution that integrates with that is going to be important. So it's the first thing we're always going to look for when protecting Kubernetes. Can I do everything just with manifests? I don't want, and this will, I sometimes get made fun of for this, but in a lot of ways, I don't want a GUI. I want to be able to trigger all of these things just with custom resources against the custom resource definitions of the product. I guess I didn't put this bullet point on here, but with all of the companies I've talked to, the ones that are, the line of who is successful at disasters and who is not tends to follow who's tested it. And the closest, and as close as you can get to verisimilitude with that, where we have this, our mock disaster, where we're actually swinging users over, where we're loading it, where we're pretending this is a real thing, those companies tend to be very successful in the event of a disaster. Okay, I think that's it before.
Yes,
okay.
Thank you. So I'll talk now about how Rancher and Portworx solve for resilience. I'm a marketer. I can't not put this slide up here, but IDC has a new category called container data management. Portworx has been Portworx by Pure Storage, I should say, has been recognized as a leader in that space for a couple reasons. One being our enterprise-grade feature set. Another being similar to Rancher, being able to plug into pretty much any infrastructure. And then also being able to run these mission-critical applications like the ones I've been talking about today. So in the next slide, you'll see that we have partnered strategically with SUSE and Rancher, and with Portworx as the container data management solution and Rancher as the container management solution, we help organizations like yourselves unlock the value of Kubernetes data at enterprise scale. That's through optimized storage performance, through that enterprise-grade business continuity that I'll talk more about, and then again with that unified storage no matter where you're placing it. And a little bit of intro into who Portworx is. We are a software-defined storage solution. So we provide streamlined management for persistent storage. We provide that disaster recovery. We provide data protection, all of that good stuff. We do also have a database as a service product called PDS, or Portworx Data Services. If you want to learn more, Tim Darnell, who is our colleague, made a pre-recorded session that's available after SUSECon. So I'll imagine it's available immediately after you get out of this room. If you want to download it, listen to it on your flight, or listen to it like a podcast in your car on your drive home, I highly recommend you do that. He does a much better job of explaining what PDS is than I ever could. But Portworx, from the storage side, helps provide that automated capacity management, some of the optimized application performance. I won't dive too much into this. But one of the reasons why we have partnered strategically with Rancher and SUSE is because similarly, we enable that choice. You can plug into any infrastructure, whether that's on-prem, in the cloud. If you have hybrid or multi-cloud deployments, we're pretty flexible in that regard. And although we do have a strategic partnership with Rancher, both as a managed service and as a Kubernetes distribution, we do fit in with other Kubernetes distributions as well, again, enabling that choice. Cool, and I do want to double click a little bit into the DR component. Portworx is able to provide both synchronous and async DR. I did talk about sync DR a couple slides ago, but just to reiterate, anytime you're making changes in your production copy, they're immediately being made into your DR copy as long as they're within the same metro region. And if there's a failure, an outage, what have you, the first cluster goes down, you just need to fail over into the DR cluster, and there should be no delta between the data of the two. With async DR, this is much more popular among Portworx users, but async DR, you can set it at whatever schedule you like, whether that's 15 minutes, 30 minutes, couple hours, days, and that really gives you those flexible policies so that you can match the DR component to what your application actually requires. And these don't have to be within the same metro region. If you want to put it between two different data centers, you can. And like I promised, I'm going to talk a little bit more about Rivian. I'm sure you recognize their car right here, but for those of you who don't know, Rivian is an electrical vehicle manufacturer over in the US. They use microservices to power their manufacturing processes on their factory floors. I'm sure many of you can imagine, even if you're not in the manufacturing space, but anytime your factory floors are down, that means you're losing money. Your product's not being made, it's not good. So for Rivian, it was extremely important that they had a highly available solution that could provide the resiliency they needed for these critical applications for them. They're always trying to make their manufacturing processes faster and faster, and you definitely don't want an outage at any point during that time. So with Portworx, with Rancher, they've been able to achieve that resiliency. They've claimed they have uninterrupted data access and that they have a highly available, secure solution using both of our products. So we've been able to deliver this to real customers, and if you want more examples, feel free to talk to me later, but demo time.
Oh, all right, we're back to me. Okay, so because I love demos, everything about them, the stress, the potential of a power outage, all of those things. I do have a backup recording just in case. But what we're going to be doing is we're going to take an application and we're going to fail it over between RKE2 clusters. I want to talk a little bit about structurally the things we're going to be looking at here, because there's two components that we're really replicating. I am going to be taking both persistent volumes as well as all of the Kubernetes manifest objects and replicating them between these two clusters. That's going to happen on a timer. Then, for my recovery, I'm simply going to scale the applications on the destination side. I've pre-done all of the DNS bits, so we are going to hit a different URL with the whole thing. All of the things that I'm doing are going to be inside of Kubernetes custom resources. So when we integrate this sort of thing with pipelines, if anybody, was anyone here at KubeCon? A couple? Okay. Stephen Atwell and I from Harness actually had a talk there using some of these in creative ways along with GitOps pipelines, because after all, if I can have a pipeline also have the ability to move data around, either triggering this as a one-time thing, updating a secondary DR copy, or even activating a DR plan, I can use that for more than maybe just DR, for things like application, complete end-to-end testing with actual copies of the data. Although my environment, my two RKE2 clusters are going to be the same, it doesn't matter really where these are running. From a Portworx perspective, I could have SAN attached disks on one side and local disks on the other. I could be running on premises and for my source, and then maybe in the cloud as my destination. So for the most part, we really don't care. Okay, which means I actually have to get out of here and hope that everything stays up, because I have been having a weird power issue at home. But we'll make sure everything's up. Okay. So let's take a look at our environment here. How difficult is that to read? Let's do that. A little better?
Yeah.
Almost? Okay. All right, so I have two clusters that are creatively named production and DR that I'm going to be using here. So first, let's go ahead and take a look at our application. This is Frank. Frank is the owner of Portworx Barbecue, which is a barbecue ordering application. And unlike what I said earlier, where it really doesn't matter for business, this is certainly an e-commerce store. By the way, this works, so if people want to go to www.pxbarbecue.com and put in orders, that is just fine. The chatbot is a little underpowered. This is actually all running out of my, we'll say in quotes, data center in Tacoma, Washington. And there's a slightly underpowered NVIDIA card that's powering that thing. But it is an actual chatbot that says, oink, oink, a disturbing amount. So let's take a look at what this looks like. Well, I have some data here, but let's go ahead and put in a new order for barbecue. By the way, folks can always register and put in their own orders, but I'm feeling a little like some barbecue chicken, some fried pickles, some Brussels sprouts, and of course, the pork special. Now, pay attention to this order number, because this really is the persistence here. So let's take a look at the underpinnings of this application for what I'm actually going to fail over. So I'm going to head into my production cluster, take a look at workloads, and figure out where I'm actually at. There we go, Frank's Foods. And I have a Mongo database backend, and I have a Golang web frontend that's actually powering this application. Now, I want the entire thing to fail over. So in my case, like I mentioned, I am going to be moving all of the manifests with this particular tool. But because they are all just manifests, we could put this inside of whichever Git pipelines we want. So that's the application. Let's take a look at a little bit of the Portworx infrastructure and the custom resources that are doing this pairing. So Portworx is running on both of my RKE2 clusters. We can see the PVCs that it's serving, the nodes that I'm running, as well as the drives. For those that don't understand or haven't seen Portworx's architecture before, I'm taking local block devices, however they're being presented to me, and I'm putting that into a pool of storage. From there, I'm going to be handing out persistent volumes to my application. So it's not like a pass-through or anything else. That's also why, even though these are local disks, they're still resilient. Within this cluster, my persistent volumes have multiple copies within the cluster. So let's say I'm using local NVMe devices, that's still going to be resilient, because if I lose a node, well, I had another 2 copies somewhere else in the cluster, my pod simply restarts there and uses that underlying storage. Okay, so how are these clusters set up and paired together? And by the way, I won't drag everyone through, but the DR side of things actually has, of course, has Portworx installed as well. And turns out in this case, it's configured identically. All right, let's go back to production. I'm going to hit the handy, by the way, this is probably my favorite feature of Rancher Server, is they simply allow me to hit any custom resource from the GUI no matter what. So from a demo perspective, this can be really nice to just click through things. Okay, so I'm going to take a look at the cluster pair, and we can actually see here that I have a manifest, and for those that really take pictures fast enough can probably get into things, but I promise this is actually all behind some firewalls. But this manifest contains information about, one, how these two clusters are talking from an administrative perspective, so imagine SAs with tokens and the endpoints of my other cluster, as well as from a Portworx perspective, API endpoints with Portworx. The other thing that's in here is I'm actually in an asynchronous scenario using some form of object store or NFS export as essentially the transport. So I'm sending to an object store, and that's being immediately picked up when it goes to the destination. So I do have a min.io instance that's actually running in here as well. Okay, so once I've created this object, and by the way, I'm showing manifests here, but we do have a utility where you just say stork cuddle pair, and it'll automatically pair these things. But I love looking at the how I would do this if I'm using GitOps. Okay, so that's the cluster pair. The next thing that I've created is a migration schedule. And a migration schedule, in my case, is for the purposes of DR. It's going to say how often I'm going to be replicating this, as well as what I'm going to be replicating. Now, I didn't show, but there is policies where I can have different and custom schedules that I put in here. But in my case, I'm going to be replicating this PX barbecue namespace from my source cluster to my destination cluster. There's a few other things in here that I won't spend too much time getting into right now. Well, you know what, let's, every 30 minutes, I know, I like to change, I think I may have ADD. I don't want to wait 30 minutes for that replication to actually happen, so I'm going to go ahead and trigger a one-time replication that's out of sequence with my every 30 minutes. So if I still have it up, I'm going to grab, surprise, surprise, another custom resource. And by the way, this migration schedule, really all it's doing is it's creating these migration CRs on a timer. So I'm just going to go ahead and create one. By the way, if I was really doing a migration, this is probably how like a one-time migration, this is probably how I would do it. All this really has is information like, hey, where, of course, am I putting the manifest, as well as what's the cluster pair object, because as you can imagine, I may have more than one. It also includes things like, do I want to grab resources? Those are the manifests. Do I want to grab volumes? And yes, I can support things like label selectors. So in some cases, I don't want to replicate certain things. Very oftentimes when I'm using GitOps pipelines as part of this DR deployment. Importantly here, I'm not going to start the application. So this is just a replication. I'm going to actually do that as part of my disaster in a moment here. Let's go ahead and create that. This is where I tap dance around for a minute. I think this takes 1.3 minutes to handle. So fun bits of trivia. This is actually, I mentioned running in Tacoma. The underpinnings of this are, of course, RKE2 and SUSE Rancher Prime. The operating system underneath it, though, for these virtual machines is, again, RKE2 running vanilla kubevert on top of a Gen 2 operating system. If anyone has ever messed with that thing, I would highly recommend it. It's a ton of fun. If you're a bit of a technology masochist, but you'll learn a lot by deploying it. Okay, which yeah, it might be both. The things that you learn with the vanilla bits, like, hey, I didn't know that this is where the value of these virtualization tools like Harvester really shine, because the amount of things that I didn't realize I needed to think about when it comes to a vanilla kubevert setup was pretty staggering. Like, for instance, MAC addresses are not durable by default. You spin up a virtual machine instance, it gets a MAC address. And then if you spin it up again, it has a different MAC address, which doesn't work so well because I use DHCP for everything inside of my labs. So fun little things like that. Did I stall long enough? Oh, I did. Okay, 1.1 minutes this time. So we can see as part of this particular replication, I've moved all of the manifests to my disaster recovery site. And I've also moved the data volumes that are part of it. All right. I debated whether I would just shut these things, my production systems, down in real time, but Of course, TTLs with DNS, it didn't seem as fun, so we're going to use our imaginations a little bit. But at this point, I've had my disaster. My production cluster is offline. We're not going to touch it again. So I'm going to go over to my DR site and take a look at what's here. Notice that we do support Rancher project mapping because, of course, access and RBAC are really important as part of that stuff, and we need to make sure we're putting things in the same project. And if you were a very fast reader, you saw in my cluster pair definition that I was actually mapping those projects. So let's go ahead and go to workloads, and we can see, suppose I actually have to select PX Barbecue. First, I didn't bring over any of the Gen AI stuff, so the chatbot won't work here. I'm not, my wife did not approve funding for 2 underpowered NVIDIA cards. But my stateful set and my deployment are both here. Now, I'm going to, in this case, manually scale it up, but this is not a particularly realistic scenario because I'm not going to be clicking buttons. Chances are, if I want a button to push, I'm going to use stork cuddle, and there's an activate command that simply says, whatever you had on the source side, scale it to that on the destination side. Or I may use some other automation because, again, all of the things I need are just Kubernetes objects. This is really just a scale command to recover it. So we're going to wait for Mongo to come up here. Well, it's Kubernetes. We're going to scale them both. And we're going to give that a minute. So Mongo's now coming up with the same copy of data that was on my source cluster. And then my web application is going to scale on top of that. Let's go to pods. Thinking. I need more jokes for any of these pods.
I was just about to suggest you say one.
Oh, okay. So now I can go to, and all of you as well, can go to dr.pxbarbecue.com. This is the same copy of my database. Let's go ahead and check order history. And we can see here that my 10,001 order actually showed up on the destination side. Portworx in this case was responsible for, of course, that data movement, but also importantly was responsible for all of those manifests. And I would also say that even in the event where I have a GitOps pipeline, I know that all of these are consistent, right? On that 15-minute timer, the version of Mongo that I was running inside of the manifest, the version of PX Barbecue, the web application was in that manifest that's synced with the data. So even if I'm using a GitOps pipeline, I can sometimes have that drift, right? Usually when I'm not doing my job. But I do like having that consistency point. Okay, that's everything with that. We'll have a moment for questions in just a minute. I think, Janet, there was a couple slides you wanted to chat through.
So before we open for questions, if you are curious about learning more about Rivian and how the work they're doing with Portworx and Rancher, we are hosting a webinar with Josh Crater, who you may have actually seen it today or this week in the conference. But that will be going live March 27th, 10 a.m. Pacific, 1 p.m. Eastern. If you scan the QR code, you'll be sent to the landing page where you can register. This will be held more like a fireside chat, but Josh will have a lot of really great insights. And also, if you want to learn more about either us or Rancher, you can go to our websites. This QR code takes you to a potential hands-on keyboard technical workshop where you can do some of the cool things that Chris was showing, maybe not precisely that, but currently we have workshops scheduled in Salt Lake City as well as Dallas. But if you have a city that you would like for these to be hosted, please feel free to talk to me after this, and we can see if we can get one kicked up where you are. And then, of course, we will be at KubeCon London in April, so please see us there if you plan on attending. And that's everything from a slide perspective, I believe.
Oh, okay.
Yes, thank you.
Yeah, appreciate it.